is a distributed randomness beacon. It periodically generates verifiable, unpredictable, and unbiased random numbers as a service. The League of Entropy run a set of drand nodes, and they are collaborating together to generate randomness every 30 seconds on the League of Entropy mainnet. And the website shows the latest randomness that is available. This is round 42,456, and in 6, 5, 4 seconds, there will be a new random value generated. There it is. So these random numbers are available over libp2p pubsub, over http cdns, but also now over Twitter, because why not? So there is a League of Entropy mainnet Twitter bot, LOE bot, and what it's doing is it's tweeting out the randomness as it is generated. And so now, because we have this Twitter relay running, I've been hacking on a Twitter client for the relay. So this is just a JavaScript client for the relay. You can install it in npm and use it in npm and also Dino. And let's have a look at the code and maybe we can demo it. So this is pretty simple. We're just importing the regular drand client, but we're also importing the Twitter client from here. We've got our chain info. This is the League of Entropy chainnet info, which we're going to pass in. And all you need is, you need to know the screen name, which is LOEbot, but you also need a bearer token, which is just an API access token from Twitter. You can go to developer.twitter.com and sign up for that. That should give you enough request allowance to be able to use this thing. So as usual, we wrap our Twitter client in a regular client, and this basically allows it to verify the random beacons as they come in. We create a new Twitter client, we pass it the screen name, the bearer token, and the chain info, and then we have a client that's ready to use, and what we can do is just watch for new randomness as it becomes available. I can use Dino to run this, using Dino run, give it access to the network. It needs to read files because I've got my credentials stored in a JSON file there, and I should just be able to hit run, and this should log out the randomness as it gets created. Hey, there we go. Round number 42,461. So after 30 seconds or so, we should get another random value be printed to the console. We'll just wait for that. There we go. Here it comes, 42,462. So this is kind of interesting because it uses the Twitter user timeline API, and that just allows you to hit it with a request and say, give me the most recent tweets by this user, or give me tweets that are after this tweet ID or before this other tweet ID. And so that makes the client good for basically getting the latest randomness and watching for randomness. It's not so great for getting historical randomness because it has to basically traverse all of the tweets that have been tweeted to find the round that you were looking for. The Twitter API is fun times, and I originally tried to use different streaming versions of it to stream for the watching, to stream the randomness as it happens, but I found that there's a new labs streaming version. There's also a different streaming version, but I found that the actual stream was slow. Like I'd get rounds that were like 11 seconds after when they had been tweeted, so that was no good. And actually, it turns out that it's better for us to just poll the user timeline endpoint when the tweet has been made, since we know when the tweet is going to happen due to the genesis time and the period from chain info. We can just go and get that when it's needed, and that actually makes the code for the client way simpler because we can reuse the polling watcher from the HTTP client because it does basically the same thing. And that's it really. I think that's pretty much it. So hey.